A OneWheel, it's like a hoverboard, but in the shape of a skateboard, just with a single tire in the middle and with more steers.
Hello and welcome to my OneWheel project. In the last video I recreated this float wheel to gather ideas for my own board. From this inspiration I created my own design, the storm wheel. Every part from the smallest cover to the massive mainframe are designed from scratch, with the goal of hopefully being able to build it with my own manufacturing possibilities.
In this video I'll be building my own 84-volt battery. I've used brand new recycled cells from a scooter battery that I took apart. It was actually pretty risky as I was still learning and figuring things out at the time. After that I design and create a custom footpad sensor, which I hope will offer more safety than the small sensors you usually find. Finally, I'll search for the perfect tire to handle the power of my 4 kW monster motor and bring it to the road. Let's get started with the project. I'll show you my CAD model and explain how I plan the integration of my custom battery. It's housed in a modular box beneath the footpad. Initially, I planned a 20S2P battery with the maximum voltage of 84 volts, but a comment from a viewer made me realize that this would push my motor controller to its limits. If the voltage exceeded that during braking and recovery, it could cause damage or even a crash, so I opted for a smaller 18S2P battery instead. But the advantage is that we save 4 battery cells, even though it means we lose a bit of performance. Given the limited space though, it's a good solution. Before we start saving cells, let's first break down our part source to gather the materials for the battery. So when I break down this battery, I'm getting 52 cells, but I only need 36 for this project. That means I can keep a few aside for future projects. Now, I want to point out that disassembling a battery can be dangerous, and I'm not an expert. This is just me sharing my personal experience. Honestly, there was a moment when I had sweaty palms because I was worried I might make a mistake. If you see any safety issues, please let me know in the comments so I can do better next time. I'm trying to recycle as many parts as possible, especially the insulation paper, which I'll need later. As you can see, there are quite a few sparks flying. You really need to use a fully insulated side cutter to prevent that. Now let's quickly refine the battery terminals with the diamond grinder and we can begin building the battery. I know, these aren't the best battery cells. They were advertised as having 5 Ah per cell, but realistically, you can only accept around 3.5. And yes, the insulation of the cells has been compromised. The question of why I didn't just order new cells instead of using this is completely valid. If I were to do it again, I would choose high quality cells instead of using cheaper ones from a budget battery. I cut the recycled fish paper into long strips to wrap around the exposed positive terminals. This ensures that when positioning the batteries later, there's a gap between the cells and they don't touch each other. I got this trick from another YouTuber, who also built a battery for a OneWheel. I'll link his channel below. He made an excellent tutorial that I highly recommend. Since I expect high vibrations and possible even some impacts on my OneWheel, I want to ensure that the cells are well protected from vibrations. Thanks to the preparation I just showed you, I can now securely fix the batteries together with heat-resistant hot glue. To properly weld the battery together, I bought a transistor spot welder from Amazon. It didn't have any good reviews, but I still wanted to give the device a try. To power this device, I use a car battery that I had from an old project. It should provide enough power for a clean weld. I connect the individual cells using these nickel strips shown here. Since I'm not entirely sure how good the welds will be, as I have no experience with this, I'm simply applying multiple welds to be on the safe side. To prevent the nickel strips from shifting during welding, I secure them with small magnets. To properly connect the balance cables to the individual cells later, I prepare small welding tabs. I spot weld them between the cells, then fold them upwards, making it easier to solder the cables onto them later. For the isolation between the battery halves, I'm using Kevlar material from the recycled battery. To make sure I can easily identify the cells pairs later, I'm adding a numbering system based on the sequence you can see in the graphics here. For the first protection layer at the poles, I use Kapton tape, and to add more stability, I connect the cells with Kevlar tape. Finally, I apply fish paper at the front and back for extra insulation. I'm now connecting the two halves using hot glue and the same materials as before, Kevlar tape and Kapton tape. Considering this is my first time doing this, I think it's already looking pretty good. Now we are getting to something I actually enjoy, soldering. Back in the 5th or 6th grade, I took an electronic course, and that's when I first got into it. I still remember building a really useful device, an electric shocker. Hopefully I won't get shocked by my battery here. Did any of you have similar courses in school? I've pre-tinned the small nickel strips with solder to easily and cleanly solder the wires going to the BMS. Then with great caution I connect the positive and negative terminals of the battery. At this point it's important to be extra careful, since there are 75 volts involved. In the last video, I had to break all the parts into smaller pieces, because my printer was way too small. But I finally stopped being so cheap and upgraded to a bigger 3D printer. Now, all the parts I need for this project fit perfectly. The housing is printed from PETG because it's more temperature resistant and flexible than PLA. To be able to screw on the lid later, I'm using brass insert nuts. A large part of the connections was already covered in the previous video. Now I'm going to create a Y splitter that will be connected between the battery and the 120 amp fuse. This will power the BMS for charging, while also directly supplying power to the motor controller. The setup uses a charge-only BMS configuration, which allows me to adjust all safety-related settings directly in the VESC tool, without being limited by the BMS power restrictions. Thanks to the included Wi-Fi antenna, I can check the BMS directly through a mobile app. This allows me to see live whether the individual batteries are doing well, for example, if the temperature is too high or if the cells are charged unevenly. These are all safety-related aspects that I can keep an eye on. Since my batteries are so cheap, they are as tame as a cheap, but as a wool package, I hope they will be as strong as a wolf. I originally bought two ready-made footpad sensors, but they were just too small for my taste, so I decided to build my own. It consists of 3 layers, a bottom part, a top part and a thin layer of Velostart. Velostart is a special material that changes its resistance when pressure is applied. I take advantage of this property. When I compress the sandwich structure, the resistance is decreased and the footpad sensor gets activated. You can think of it like a variable resistor, but one that responds to pressure. The bottom layer of my sensor is made of PETG. The pattern you see here is essentially my circuit board, but I have to apply copper tape to it myself. The previously drawn structure makes this process much easier for me. There's a left and a right field, so later on I will have 2 sensors. No, this syringe doesn't contain any drugs. Much better, real silver glue. I use this conductive glue to connect the individual joints, and showing the connections are perfectly conductive. Normally, you solder these connections, but plastic and solder don't go very well together. The top layer of the footpad sensor is 3D printed from TPU, an elastic material. This will hopefully provide more responsive feel when activating the sensor, so you don't just trigger it, but actually feel the activation with your foot. I'm testing to ensure that all the connections are properly conducting. After that, I cut the velostart for the footpad sensor, creating both a left and a right side, so we have one sensor for each foot. I'd really appreciate it if you like the video, subscribe and give it a thumbs up. Also, if you have any feedback, good or bad, please leave it in the comments. It helps me improve both with the video and the OneWheel project. I carefully glue the 3 layers together using super glue. So far, everything feels very solid and high quality in my opinion. To test it, I temporarily connect the footpad sensor to my motor controller and press both sides. As you can see here, the sensor works flawlessly. It switched from 0 to 3 volts, and depending on how hard I press, the voltage is variable. I spent my money on a motor with a pre-installed tire. However, the tire only has a diameter of 10 inches and a breadth of 5.8 inches, which feels way too narrow to me. The website had listed it as significantly wider. On top of that, the rubber compounds feel cheap. It took me a long time to find a decent tire with a larger diameter and more breadth. Once that's still available, at a somewhat reasonable price. A good price, that's a joke. Paying 160 euros for such a small tire just doesn't sit right with me. It's just way too expensive. Unfortunately, from here in Germany, I don't have a quick way of getting a proper alternative tire without waiting months for delivery. Nonetheless, the Pin Performance tire makes a great impression on me. It's larger in all the right places and has an excellent rubber compound. Unfortunately, I don't have any special tools to change the tire, but I saw a video where they showed how you can easily remove the tire with clamps. In the video, it looks really simple. However, when I tried myself, I really struggled to get the tire off. It definitely wasn't as easy as it seemed. It was almost absurd how easily I managed to get the new tire onto the rim. Even when inflating the tire, it went smoothly without any issues. Normally with this kind of tires, you did expect explosive pressure to get them seated. But here, it wasn't a problem at all. That's it for this video. In the next one, we'll get down to business. I'll CNC machine the main frame from aluminium, finish the footboards from wood and 3D print the front and rear bumpers. And who knows, maybe we'll even have the first ride in the next video.